Hello everyone, in this video I'm going to be going over the scientific practice of using mathematical thinking, but instead of solving physics scenarios or word problems, we're going to be looking at proportional reasoning. All right, so what is proportional reasoning and why do we care? We could always solve problems like this, right? This is a helpful way to go about it, but um, proportional reasoning sometimes just allows us to solve problems quickly where we don't have to go through all this work, right? Also, there's going to be some times where we don't have all the variables needed to plug into the actual equation to get the actual value. So proportional reasoning is another cool trick that we could use to solve problems. And so what actually is proportional reasoning? It's the idea that if I change a variable, right, in any way, let's say I double it, but I could half it or quadruple or do anything to it, but let's say in this case that if this x variable doubles, then maybe there's another variable in the equation, maybe it's y. How does that change? If x doubles, does y also double? Or maybe if x doubles, y actually halves. Or maybe if x doubles, y also increases, but it actually quadruples instead. That's what proportional reasoning is. All right, so let's actually look at a specific scenario. Here's our problem. You are traveling from the new east building all the way to the end of the west building, and you're tired of walking, so you invest in a golf cart to take you from the attendance office to the point. Normally, this would take you 2 minutes going at a constant velocity. However, with the golf cart, your velocity is now 3 times greater. If you travel the same distance as before, right, what is your new time? Right? The golf cart also travels at a constant speed as well. All right. So we're not given a whole lot of information here, right? We don't know the actual how fast you were going, the actual distance it is from the attendance office to the point. I don't really feel like going out there to measure it, but that's okay because proportional reasoning allows us to solve this problem without any of that information. So very similar to what we did with word problems is we are still going to choose an equation, right? And we're going to use our physics concepts to help us out with that. Now, in this case, we haven't really gone over a whole many physics concepts yet. We've just focused on constant speed. So choosing the equation doesn't become too difficult. We're going to use this one right here. Right? Now, notice that these two are the same equation, but they're just written a little bit differently. And the reason why we write this one, or why we might use this one written right here, is it's really helpful for proportional reasoning. All right? The reason why we don't really use this one is anytime you kind of have this addition sign in here, it just makes proportional reasoning a whole lot more difficult. But anytime your variables are just being multiplied by one another, it makes it so much more easier. So that's why we're going to use this one right here. So we're going to put in our equation. Delta x, change in position, is equal to velocity times time. All right. Now, before, what we would used to do is we used to plug in the actual numbers, but we don't have actual numbers. All right, so we're going to employ this method. I call it the one-to-one method. All right, since we don't have all the numbers, let's just make up our own numbers if we're not given any, right? And then the question is, well, what's easier than using 1 as just a completely arbitrary number? Nothing. Nothing is easier than using 1, so that's why we're going to use ones most of the time as our foundation from starting this. But let's explain how that works. You don't have to do this every time, but since this is our first time going over this, I'm going to talk about our original scenario. Right? In our original scenario, I'm still going to use this equation, and for the distance, I don't know the actual distance, so I'm just going to plug in 1. Right? That's not the actual distance, but that's fine. That's the easiest arbitrary number I could use. And my velocity, I don't really know the velocity either, so I'm just going to plug in 1. Now, the time is what we're looking for. We're curious on how time changes, so I'm going to leave that there. And if I were to solve in this equation, well, what 1 times what would give me 1? Well, just 1. So my original time in this case is 1. Now, obviously, this is not the actual time. There's no units on it, but it's going to be kind of our reference, our point to go back on. So if I look at my new scenario with the golf cart, here I have delta x, and so I want to see, like, in my new scenario, how did these variables change, if at all? So for instance, it says that I traveled the same distance as before. That makes sense. I'm going from the point to from the attendance office to the point. That distance hasn't changed. So my distance before was 1, so I'm just going to keep that as 1. Right. Now, what about my velocity? Well, it says my velocity is 3 times greater. Right? And so instead of using 1, well, 3 times greater than 1 is 3. So I'm going to put a 3 in. So notice that using the one-to-one method, how easy it is to kind of change these variables in relation to one another. So then I'm going to solve for time. Now, some of you guys might be looking at this and be like, all right, I could kind of figure out what the time would be in my head. I will say that this proportional reasoning, even though this is a simple example, it will start to get more difficult. So it's really helpful to get these essential components down when we start to go to more difficult problems. All right. So if I solve for time here, all right, I'm going to divide by 3, divided by 3. These cancel out. So my time, or my factor of change, ends up being 1/3. Right? Now, when it comes to solving with word problems, I'm a stickler for units. You have to have the units. But with proportional reasoning, this isn't your actual time. It's just a factor. What it's saying is that, hey, compared to the original time, this time is going to be 1/3 as much. That's it. All right. So no need for units. Now, remember, what this problem asking is if I travel the same distance, what's my new time? So it's not saying like what's the factor, but what's my actual new time? So I have to apply that factor of change to answer that question. So what I'll do is I'll say, okay, well, what's my original actual time? So my original time, that was 2 minutes. And then I'm going to multiply that by the factor of change. You always just multiply it. And that's going to be 1/3, right? I solved it right here. Right? And then that's going to give me my new actual time. Right? And that's going to be 2/3 of a minute. Right? If you multiply those together, another way we could say that is that it's just 40 seconds. All right. So for now, ignoring this box right here, for now that concludes introducing the scientific practice of mathematical reasoning, specifically as it pertains to proportional reasoning.